Welcome to ROHM Semiconductor's product training module on Configurable Power Management Integrated Circuits, or PMICs, for NXP Applications Processors. The purpose of this training module is to provide a brief overview of ROHM's PMIC offerings, explain benefits, and show how the products work with NXP Applications Processors. Let's begin with the basics. When we first discuss PMICs, we should first discuss DC-DC converters and LDO regulators. These devices come in many flavors, configurations, and have their own advantages and disadvantages. But essentially, these devices are the core building blocks from converting DC-DC voltage from one level to another. Knowing this, we can talk about power management ICs, or PMICs. These devices are integrated circuits that include multiple DC-DC converters, LDOs, and other items in a single chip. This can help reduce overall space and simplify overall system boot up for specific applications processors. Today, we want to talk about the applications we support. Primarily, the PMICs we are discussing today will be for the NXP Applications Processor solutions, specifically the i.MX series processors. This is the simplest setup we can use because with the NXP i.MX processor, we already have a pre-validated solution and partnership between NXP and ROHM. However, non-NXP processors can also potentially be supported by these PMICs. This includes small FPGA or system MCU PMIC solutions, as ROHM's PMICs are fully configurable, from rail boot-up sequence to different default output voltages. Please contact a ROHM representative to see if your system can be supported by one of our PMIC devices. Here we can see all ROHM's available PMIC devices and how they cross over with NXP's lineup of system application processors. On the y-axis, we see the available ROHM product, and on the x-axis, we see the matching NXP system that can be supported. As seen, ROHM has products to support NXP's full lineup of products down from the i.MX6 up to the i.MX 8M, along with the i.MX 8M Mini and Nano variants. This slide shows the value propositions of ROHM's PMIC pairing with NXP's application processors. First, ROHM's PMICs represent a highly integrated and optimized solution for the 8M for the lowest system BOM cost. This system PMIC supplies all the power rails required by the i.MX 8M, memory, and system peripherals. And this is all capable of working on a low-cost Type 3 non-HDI 6-layer PCB. Additionally, this PMIC allows for high system efficiency and overall low power consumption, capable of outputting 83 to 95% efficiencies over the different rails and loads, along with a very low 30 microamp deep sleep operation mode. This solution is also highly flexible. OTP configurability and software programmability allows for different default output voltages, power on sequences, and power state transitions available for your different system designs. And if a more compact solution is required, this device can be used to generate a 250mm² SOM on a 10-layer PCB. This is possible with pinout matching with the i.MX 8M Mini for easy PCB routing, and utilizes very small 0.47 microhenry inductors. Finally, ROHM's PMICs are proven and optimized for the NXP product line, since ROHM is partners with NXP, and our PMICs are on NXP EVKs and reference designs. This slide shows us a little more detail about the PMIC devices that support the i.MX 8M Mini and Nano devices. Specifically, we have the BD71847AMWV for the Mini and the BD71850MWV for the Nano. As mentioned before, for an inexpensive solution, this device can work on a 4-layer PCB. Running this solution requires a footprint of about 325mm². This device contains 6 buck regulators that can operate at 1.5 or 2 MHz switching frequencies at a plus or minus 1.5% accuracy. There are 2 rails that include dynamic voltage scaling, or DVS, which allow for 10 mV step capability for precise power control. Additionally, these regulators can work in either PWM, PFM, or auto mode depending on the power control load required or expected. Finally, these rails also include a configurable phase offset capability per rail. Another notable feature of this PMIC is the OTP configurability for the power sequencing and default output voltages. This is what allows the PMIC to be used with other system applications like FPGAs and other applications processors. The overall system PMIC has very low power consumption for battery-powered applications as well, with numbers like 12 microamps in an off state, 20 microamps in the SNVS state, and 126 microamps in the suspend state. Here we can see a block diagram of the BD71847AMWV operating with the i.MX 8M mini applications processor. We can see that all the rails for the i.MX 8M mini can be fully supported by this PMIC, from the SoC and the ARM processor to the memory and the GPU. This PMIC has the system fully covered with both the voltage rails required and the correct sequencing needed to properly bring up the system. This diagram shows how to migrate from an existing i.MX 8M mini to Nano design. For this activity, note that the BD71847A MWV and the BD71850 MWV are pin-to-pin compatible and can act as a drop-in replacement. In order to fully optimize the power side of migrating to the Nano design, we only need to depopulate 2 voltage rails and change the part number to properly account for the new sequencing for the Nano design. Here we can see a block diagram of the BD71850 MWV operating with the i.MX 8M Nano applications processor. As I mentioned before, the only main difference between the power side is to depopulate 2 rails, Buck 5 and LDO4. The BD71850 automatically adjusts the power sequencing for the change from the i.MX 8M mini to the Nano configuration. Here we can see many design tools that are available for development. NXP has a full 8M reference design that incorporates our BD71837. They also have an 8M mini EVK that is populated with the BD71847. And finally, there is an EVK for the 8M Nano that uses the BD71850 with DDR4 memory. Additionally, if you want to evaluate ROHM's PMIC separately, there is a standalone evaluation board available for this as well. Next, we want to highlight specific part numbers available for the i.MX 8 solutions. Specifically for the i.MX 8M Mini, we have 2 flavors of part numbers. The BD71847AMWV with the suffix -E2 is primarily for standard or industrial applications and supports -40 to 85C. The BD71847AMWV with the suffix -LBE2 indicates use for extended industrial applications that require higher temperature profiles of -40 to 105C, support for 5-year continuous on-time specification, and can last 100,000 specified power cycles. Additionally, we wanted to show the official part number for the i.MX 8M Nano as the BD71850MWV-E2, and finally, for the standard i.MX 8M solutions, the part number to look for is the BD71837AMWV-E2. All these part numbers are in MP now and have a longevity of 10-year minimum guaranteed and have a lead time of 16 weeks. In summary, ROHM makes power management ICs that include multiple DC-DC converters, LDOs, and other items that help completely power applications processors. These PMICs help provide a highly integrated and optimized solution for the NXP i.MX 8M for the lowest system BOM, while providing excellent power efficiency, system flexibility, and options for a highly compact system or cost-effective 4-layer design. Finally, ROHM has solutions specifically for the NXP lineup of i.MX 8 products. Most recently, we've put together solutions for the i.MX 8M Mini and have an easy plan to migrate to the i.MX 8M Nano platform solution. If you have any questions, please feel free to visit our website at www.rohm.com for more information on these configurable PMICs for NXP Applications Processors.